There are several different methods we can use to solve quadratic equations. Just a reminder, the standard form of a quadratic equation is what we call ax squared plus bx plus c equals 0. It is important when using some of these techniques that you start the equation in standard form. And by the way, a quadratic equation is also known as a second degree polynomial. So one technique we can use to solve quadratic equations is factoring. This does not work in all situations. Not all quadratics will factor. But when they do factor, it's really the fastest way to solve these. So x squared plus 5x subtract 6 equals 0. Using guess and check, factoring this to x plus 6, x subtract 1 equals 0. Here we're actually checking for our guess and check to make sure it's factored correctly. Once it is factored, we can set each factor equal to 0 using the zero factor property and solving for x. Now, a quick way to check solutions is to go ahead and graph y equals x squared plus 5x subtract 6, and the x-intercepts of the graph will correspond to the two solutions of the quadratic equation. So another example over here, 2x squared plus 5x equals 3, getting it in standard form. This one you might find a little more difficult to factor by guess and check. Others of you may find it very easy to factor by guess and check. But if you do want to, you can expand the trinomial into 4 terms using 6 and negative 1. This is what we call the AC method of factoring. Once we've expanded it, we can factor like terms out of each pair of terms here, and then we see we have a common factor. We can factor out the x plus 3 to get the 2x subtract 1. I'm sure many of you can go straight from the standard form here to the factored form without using that AC method. If you'd like to know more about the AC method, please let me know. I'll be happy to explain it further. And again, once we have the quadratic factored, we set each factor equal to 0 and solve for x and get our two solutions. Quadratics may have 2 real number solutions, they may have 1 real number solution, or there may be 2 imaginary or complex solutions. Now the square root method we can use whenever we've got something squared equal to a number. If x squared equals b, then we know that x equals to either the positive or negative of the square root of b. So with our first example here, x squared plus 25 equals 0. We isolate the squared term and get x squared equals negative 25. Taking the square root of both sides, we get x equals plus or minus, don't forget that. The square root of negative 25 is 5i. The square root of 25 is 5, and the square root of negative 1 we've defined as being the imaginary term I. Now for the second example, x plus 1 squared equals 7. We have a binomial here that's squared and equal to a number, so we can still use the square root property, since you're taking the square root of the entire side, and the entire side is squared. So the square root of x plus 1 squared is simply x plus 1. The two functions, squaring and square root, undo each other. But on the right side of the equation, we have to remember that plus or minus, and the square root of 7, which by the way is a real number, but an irrational number. So it's somewhere between 2 and 3. It's not a number we can easily write as a decimal because it has what we call a non-repeating, non-terminating decimal. So it's easier to leave it in this form rather than trying to turn it into decimal. Now we could then subtract 1 from both sides, giving us x equals negative 1 plus or minus the square root of 7. If you're interested, I just kind of did that in a little more detail here. Completing the square is a technique that often gets forgotten. It's going to be useful in a couple of other different sections, so even if you hate using it, take some time, learn how to use it. Okay, our first example is pretty straightforward. The numbers come out nicely. If we got x squared plus 2x subtract 8 equals 0, to complete the square, we first bring the 8 over to the right side of the equation, and now we need to find the magic number. We get the magic number by taking whatever's a coefficient of the x term, in this case the 2, divide it by 2 and square it. So it's a coefficient of x divided by 2 and squared. In our example, that gives us a number 1. So we take the number 1 and add it to both the left and right side of the equation. What you do to one side, you do to the other. And that will give us the left side of the equation, something that will factor very nicely. It'll actually factor into 2 identical factors, x plus 1 and x plus 1. That should always happen. If it doesn't happen, something went wrong in how you found your magic number. Once we have these matching factors, we can then write it as x plus 1 squared, and then the right side of our equation, after we added the 1, we've got the 9. And now we can solve by the square root method. Taking the square root of both sides, x plus 1 equals plus or minus 3, subtract the 1, negative 1 plus 3 is 2, and negative 1 subtract 3 is negative 4. This one came out very nicely as far as the numbers. Our second example here takes a little more work, and we have a lot of fractions to deal with. One thing we do have to be sure to do here, before we complete the squares, we need the leading coefficient to be a 1. So this example, we already had an understood 1 here in front of the x squared. Here we have a 2. So first thing, we need to divide every term in the equation by 2. That gives us x squared plus 5x subtract 3 halves. Again, we'll move the constant to the right-hand side. And now we need to find the magic number. So we take the coefficient of x, in this case a 5, divided by 2 and squared. 5 squared is 25, 2 squared is 4. It will be easier to leave this as a fraction, so go ahead and do that. Add the 25 over 4 to both sides. The left side factors into x plus 5 halves and x plus 5 halves. The right side, we can get a common denominator, simplify to get the 31 over 4. Write it as a completed square, and we can now use the square root method, square root both sides, bring the negative 5, the 5 halves over to the other side, and you can either leave it as two separate fractions or combine it, so we've got this common denominator, into a single expression. Okay, then the quadratic formula you may remember. Ax squared plus bx plus c equals 0 is our standard form. Important that you're in standard form before you use the quadratic formula, or else your signs are going to turn out wrong. And then the quadratic formula, x equals negative b plus or minus the square root, b squared subtract 4ac all over 2a. Okay, so first need to get this in standard form. So bringing the x and the 1 over to the left side of the equation. Okay, had a little interruption there. So getting back, put it in standard form. Ax squared plus bx plus c equals 0. In this particular example, a, b, and c are all equal to 1, so it's going to be kind of hard to make any mistakes in our formula. Substitute our values in, simplify. We do have the square root of a negative, so we are going to pick up an I in our final solution. And there are several different ways you can leave your answer. Negative 1/2 plus or minus square root 3 over 2 times I. Some people like to put the I in front of the square root, or we could combine the two together here and have everything over the 2. Second example here, same sort of thing, just the numbers are a little bigger, a little more awkward. Again, you want to make sure that you're in standard form, so you got to bring the 15 over and make it a negative 15. Otherwise, the value of c is going to have the wrong sign. That's going to mess everything up in our formula. So simplifying, as bad as this looks, it actually is a perfect square. We can simplify, reduce our fractions. Some suggestions for working with story problems. Read the problem and read it again until you're sure you understand what's going on. Some story problems, you can make a sketch, a table, a diagram to help you sort out the information. Think carefully about what it is you're trying to find. Often whatever it is you're being asked to find is what your variable is going to be when you set up your equation. And the main thing is write the equation, solve and check, and think about whether or not your answer is reasonable. So say you know the scores on your first 3 tests in a class are 75, 82, and 79. What score do you need on the 4th test in order to have an average of 80? So we're looking for our score on the 4th test. That's going to be our variable, x equals score on the 4th test. To find the average, we take our 4 test scores, we just don't know what the 4th one is, divided by the number of tests equals the average. And then we can solve for x. 27-inch TV screen has a 4:3 aspect ratio. What is its height and width? The 27 inches refers to the diagonal measurement on the TV screen. And we know the ratio of the length to the width is 4 and 3. So 4 times x and 3 times x. That's how we can set this up. And we're going to use the Pythagorean theorem. Pythagorean theorem only works with right triangles. And you may remember this as a squared plus b squared equals c squared. Be sure c is the hypotenuse and a and b are the legs of the right triangle. Then we can set up the relationship between the sides and the diagonal is 3x squared plus 4x squared equals 27 squared. And I see I have an error here. That square should be outside of the parentheses. So this would actually simplify as 9x squared plus 16x squared equals 27 squared. And then the following object model is a pretty standard application problem in a quadratic equations. Negative 16t squared, the negative 16 is gravity, plus whatever the initial velocity. In our example, we're throwing the ball up in the air at 6 feet per second, so 6 is the initial velocity of the ball. And h0 here is the initial height, and we're throwing the ball from a height of 5 feet, so that's going to be the 5 here. We're looking at when it will hit the ground, so the height of the ball when it hits the ground is 0, and then we can solve the quadratic equation.